Alright, so today we're going to do sets of numbers. And to define sets of numbers, we first got to remember the categories of numbers. And the overall category is that numbers are real numbers. And those are any number that can go on the number line. And that really opens up to anything. Decimals, fractions, integers, wholes, square roots, which are called radicals, all of those. And from that category, it breaks into two ways. There are irrationals, and there are rationals. And this is just a classification method. And the key here is ratio. Ratio means fractions. Rationals can be fractions. 2, which is 2 over 1. 1/2. 1 1/3. 0.13 because it's 1300ths. Sometimes it's easy to remember instead of rationals that the irrationals are simply any square root that can't be reduced. Square root of 4 would be irrational because square root of 4 equals 2. The only other number in the world that can't be written as a fraction that I know of is pi and e. Now, for most lower algebra classes, you don't know e, so it's pi. So if it's not a square root for pi, it's a rational. Under rational, you have three things. Integers, which are whole numbers, negative and positive, and 0. Wholes, which are simply all the positive numbers and 0. And finally, natural numbers, which are the counting numbers. And I always remember naturals by the trick of, if I was counting as a little kid, I always went 1, 2, 3, 4, 5. That's natural. Well, that's natural number. And a lot of times we'll designate them by sets. Alright? So these are the real numbers, and reals we can do with the symbol R of this. So, we left our table up, have some examples. So the question is what is half? Well, if I look, I think half is a rational fraction, and every rational is a real. So when it asks for sets, I'll say rationals and reals. Positive 3. I know positive 3 is a natural number, which means it's a whole number, which means it's an integer, which means it's a rational, which means it's a real. So I can label the whole way. Here we go. Natural, whole, integer, rational. Now use the funny R for real. 2 square root of 3. Use this on purpose. Doesn't matter about 2 because square root of 3 is an unreduced thing, so it's an irrational and a real. And this just gives us the ability to talk about numbers. If I add 2 irrationals, they have to stay irrational. If I add 2 rationals, they have to stay rational. And that just gives mathematicians a way to communicate. Thanks for listening. Okay, everybody.